Hello everyone, my name is Morteza Bashsiz. I am a Linux system engineer. At this series of videos, you are going to find out how to be a good Linux system engineer. So if you want to know, stay with me. Welcome to LSE episode 12. At this episode, I am going to talk about Linux boot process, details of boot directory, what is bootloader and how to configure and manipulate your bootloader, and at the end I will show you how to fix a broken grub with a real example. So let's start it. So let's start at first with talking about Linux boot process. When you power on your computer, the CPU will check the RAM for the next steps and it will execute the BIOS from the RAM. So the BIOS is the first program that executes on your system. BIOS is abbreviation of Basic Input Output System, and it is responsible to do some basic operations when you power on your computer. And one of the important things and responsibilities for BIOS is checking to find the bootable device. And also you can configure the boot priority among your devices in your BIOS. For example, imagine that I have a floppy reader and CD reader and also hard disk on my device. Then I define this priority. At first check the floppy, then check the CD-ROM, and at the end check the my hard disk to find the bootable device. And BIOS will follow this priority to find the bootable device. And if you paid attention, when your CD-ROM is higher than your hard disk in your BIOS configuration, when you power on your computer, it will turn on your CD-ROM for a second to check that if exists a bootable device in your CD-ROM or not. So BIOS at first will check my floppy, then my CD-ROM, and then my hard disk to find a bootable device. And how BIOS detects that this device is bootable or not. BIOS is looking for the first sector, the first 512 bytes, which is called MBR, Master Boot Record. This sector, which is called also boot sector, contains some data about the partitions on hard disk and also some information about the operating system. So this is the reason that this sector is usable for booting operating system. After reading this sector by BIOS, a program will be executed by the name of Bootloader. Bootloader is a program which is responsible to manage your next steps in boot process. I mean, Bootloader is a program which knows and is aware of your available kernels that you are installed on your device. For example, imagine that I have two kernels. The first kernel is for Debian and the other is for Arch. And in Bootloader, I can choose that which kernel I would like to load. And this is the bootloader. And we have also different kind of bootloaders. The most famous bootloader is grub, and the old school bootloaders know about the Lilo. Lilo is not developed recently, so it's not something that you can see everywhere, I mean, but the grub is running and everywhere in every Linux you can use it as a bootloader. And this is the bootloader that I will talk about it at this episode. After that, I choose my kernel. The kernel will be loaded to the main memory of my device. And now the kernel is running, and the kernel will execute the first process, which is called the main process, and the PID of this process is 1, and we have 2 main process in old version. It calls init, init, and also in newer version of the Linuxes we have systemd, which is the daemon for our system, and this is the main process. And after that, the main process will manage other process, like for example, when you enabled your SSH service, the main process will load and execute this one. I mean, it is responsible to handle the other processes after booting your operating system. So this is how kernel Linux boots. Power on, BIOS will be executed, and then BIOS will be search for MBR, and after that bootloader will be executed, and bootloader will give you a choice to select your kernel that you want to be executed. Then your kernel, your selected kernel will be loaded to main memory, and then it will start the main process with PID1, which is init or systemd. And then these processes, in the main process init or systemd, is responsible to execute the other processes, like your services, like your one-shot processes, like everything. I mean, everything is managed under the main process in your Linux. One important point about the MBR is a partition table, which we have another partition table which is newer called GPT, and I will talk about these partition tables and what are the restrictions in MBR and why GPT developed later to fix some issues about the MBR. And yeah, we will have another episode in future talking about the GPT and MBR. And if I want to show you examples in Linux here, what block devices I have on my virtual machine. lsblk is one command, and also blk id, block device id, and also cat proc partitions can show you that which devices you have. And I have the VDA which is mounted on my slash. Then I'm going to read the first sector of VDA, block size 512, count 1. Yeah, this is not so human readable, but I can make it more pretty with xdump-c. Here you can see that this is my first block, my first sector from my disk, which contains the MBR boot sector actually. And yeah, this is just an example. And let's see what we have in boot directory. As you can see here, there is there are some files and a directory called grub, and yeah, here in my boot grub directory you can see that there is some another files like grubcfg, which is related to configuration and the bootloader of my my device, my virtual machine, and also the other files. I am going to completely copy my boot directory to, for example, tmp directory, and then I can do some stuff, some tests on my boot directory. Here I have the same files. The first file that I want to talk about it is Init RD, which is initial RAM disk, and its initial root file system contains the basic and mandatory directories and executable files, which is loaded to the main memory to prepare the kernel and modules and load them into the main memory. Actually, Init RD, this file, looks like a small and light Linux with very basic tools, and yeah, I wanted to open this file and see what's inside. To do this, I create a temp directory, init RD, for example, and I move my init RD to init RD init RD file to init RD directory, then change directory here, and yeah, with gzip command -d as input init RD image, and also piping it to cp io -id. Yeah, you can see that I actually this file is a gzip compressed data, and with this command I decompressed it here to this directory. Then you can see that what's inside. It's really look like a simple and so basic and little Linux. And yeah, see what's inside a bin directory, for example. Here you can see that, yeah, some commands to do. Actually, this is the very basic Linux, look like a small Linux, just for initial RAM disk, and it is responsible to run and execute the commands to load your main kernel. The next file that I want to talk about it, let me back to my temp boot directory, and is VMLinus file. So if you use the file command to see the type of this file, it will show you that okay, it's a Linux kernel executable. Actually, the kernel of Linux is VMLinus, and this is the compressed executable and bootable file of VMLinus, yeah, which is the Linux kernel. In a simple sentence, VMLinus is kernel of the Linux, and VMLinus is compressed of VMLinus, and usually it's compressed with zlib. The next file is config. This file is the main configuration of the installed Linux kernel and used when the kernel is compiling. I mean, before compiling the Linux kernel, this file should be configured and it will be used in compile process. This file contains a lot of key value directories, which is specifying how the kernel should be configured. Yeah, if I choose less, you can see that there are a lot of configs here, and if I grab to ignore the empty lines and the lines which starts with sharp, then you can see that yeah, there are more than 6,000 directives to configure your kernel. And if I pipe it to less, so for example, I don't know, head 10 lines, or yeah, 10 lines, you can see that these are the configuration directives. And Linux kernel, when you want to compile the kernel, and yeah, the kernel will read this file and get the directives and will be configured based on this config. So this is the main configuration for your kernel. But this is not the file that you need to touch it. I mean, it's just before compiling, and when your kernel is compiled, so you have your compiled kernel. And also it is not means that you cannot change and configure your kernel after you compiled it. These are default values to set up and compile your kernel. And after that, when you are using kernel, you can change the changeable and configurable directives inside your kernel. The next file which I want to talk about it is system map file. This file is like a table which contains the map of your functions, variables, and everything which belongs to the kernel, inside the kernel, to a virtual memory address. Okay, imagine that this is a table and you have two columns. One column is the address of memory and one column is name of something, name of variable, name of functions, and everything. And you may not see this file in every Linux distributions, and actually this file will be generated based on one variable in the config file of the kernel. So when your sys seems, if I was correct, it should be like this. Yes. When this variable is defined in your config and you want to compile your kernel, if it is set to Y, then this file will be generated. Actually, this file will be used when you want to, in debugging, and for example in kernel crashed or kernel panic happened, it could be useful for debugging, but it is not something that you may see in different distributions. Now I wanted to talk about bootloader. In boot directory there is a directory grub, and if I list the content of this directory, you can see that there is some files, and the most important thing here is this configuration, grub.conf.cfg, and this is the main yeah, important. It's so important, and as you can see here mentioned, do not edit this file. Because this file is not something I mean, you can edit it if you know that what you want and what are you doing exactly here. If you are familiar with this configuration, it doesn't matter, you can edit it, but there is another way to configure your grub and to change the some variables and the others, and I want to show you that what is the proper way to manipulating your bootloader, your grub. As it was mentioned at this the grub.cfg, we have one directory and one file to manipulate the your bootloader. And I wanted to talk about this directory and this file, and also do something, change something inside the grub and see how to update it and what is the result of our change and the others. For this directory that it was mentioned in the grub.cfg, we have a default directory in etc, and it is the default directives and configurations for some services, and also there is a file for grub that you can see here, and if I open this file, you can see some configurations here that I can change to configure my bootloader. For example, the grub default defines that which kernel from your kernels you want to be your default. I mean, for example, you have three different kernels. The first one is for Debian, the second one is for Arch, and the third one is for CentOS, for example. Then you choose the default for 0. That means it will load by default your Debian kernel if you didn't choose your bootloader, I mean. And you have also grub timeout. It will wait 5 seconds. If you didn't prompt anything, then it will choose the default kernel image. And also some different variables, but at this case I want to disable IP version 6, for example. Here you can see that I have IP version 6 enabled in my operating system, and I want to disable it. Okay, and I want to disable it in kernel level in my bootloader. So I have a grub command line Linux. Then if I write, for example, ipv6.disable equal 1, then if I save it and run grub update grub, for example, it will regenerate the configuration. Also, there is another command, grub mkconfig, that you can see it will generate the config, and here you can see that disabled IPv6 is disabled, but it is not it will not overwrite the file. You need to send it to, for example, boot grub.cfg. And for example, I'm going to add another thing. For example, test var equal 100. It's not true, it's just an example to see that how is the output. And if I run the grub mkconfig, you can see that okay, I have this variable here, it has been added to the my Linux kernel line, and if I see the boot grubcfg, it does not exist in my at this file, and to update this file I need to do this command, or with update grub, then this variable will be added. I mean, you can simply configure your grubs, your bootloader with these file and these directories. Now I'm gonna remove this false directive and again update my grub, and you can see that notice that ntlp here is enabled, but if I reboot my virtual machine, and I will wait to, okay, it's up now, and if I again SSH and run the command, you can see that the IP version 6 is completely disabled. And this is how you can manipulate your grub. You can also do some other changes that you want, but it depends that in your case, this was just an example to how to configure and how to manipulate your bootloader. So for most cases that you want to manipulate your bootloader, this file could be enough, but if you want to do more, and if you want to deep dive into the bootloader and change some different things, there is another directory, grub.d, that you can do whatever you want in this directory. But as a Linux system engineer, you don't need to do a lot of things, some weird things with your bootloader. And if you want to change some configuration in your kernel, you don't need to change all the configurations in your bootloader in your kernel level, I mean. There are some different ways to configure your kernel in runtime, and we will talk about them in details in next episodes in future, but at the moment just about the grub, and see how the grub will work and how you can configure your bootloader. And you may face with some issues that you have a boot directory in different partition, then it is near to be full, and you cannot update your grub, and you cannot install new kernel, and you cannot upgrade your operating system. Here I just simulated the same thing. If I change my directory to boot, you can see that here I just copy these files, this kernel version to this version, to just simulate the situation. And imagine that I don't need this version and I want to delete it. Simply you can list here star if you don't want to choose keep this version, and you want to make your boot directory, your boot partition, more free for new versions, for upgrading your operating system and upgrading kernel and installing new version of the kernel. Then you can simply choose the version that you don't want to keep it, and yeah, you can move it, you can delete it by one by one, but I want to show you some commands with find here, dash type f dash I name like star, yeah, the same pattern that I used here. And with executing this command, it will list and find the matched pattern, and just use the delete option. Then I don't have any kernel like this, and you can simply run update grub to update your bootloader, and then everything is done, and you make free your boot partition, and it is available. It's more space available to install the new version of the kernel. So what we learned at this episode: we talked about the boot process, and also we talked about the boot directory and details of this directory, talked about different files and the roles of the files inside this directory, and also talked about the bootloader, especially the grub bootloader, and how to manipulate your grub and how to update your bootloader. Now I wanna show you and with an example how to fix your grub. Here I made something wrong with my grub, and you can see that my grub is not working in this virtual machine, and I want to recover. I want to boot manually from the existing images. With running command ls, you can see that which partitions exist. The only thing that you need to know is which of them contains your boot directory. Okay, so if I ls hd0 ms das, for example 5, so it's not unknown file system, and this one is my boot directory is here, so this is my main partition that contains my boot directory. And set root, the next part is setting the root directory. It's not mandatory, but it is for being more comfortable for running the commands, but always try to do the same. So I choose this root to my root file system from my partitions. Here you can see ls/ shows me something, and now I want to find my root file system partition. With cat etc fstab, you can see that dev vda is my root partition. So if I choose my Linux kernel from boot, VMLinus, VMLinus is my Linux kernel, and my root file system is dev vda1. So I choose my kernel to this with this parameter only for booting my operating system, and my init RD image is on boot, init RD. Okay, now I choose my Linux, I choose my init RD, I choose my root file system in Linux line here, and next command is running the boot command. Then you can see that my operating system is up, and now I can SSH to my operating system, but when I run the nettest.ntlp, IPv6 is enabled again. Why? Because because I didn't choose any other option for booting my kernel. I just only choose the root file system to dev VDA1. Then here I can run the grub mkconfig to build the new config and copy it to boot grub.cfg. I renamed this file to make my grub failed, and you can easily create it or with update grub. Then if I reboot my operating system, here you can see that my grub is working again correctly without any problem. And here if I SSH again and run the nettest.ntlp, you can see that I again disable the IPv6 because the IPv6 configuration was in my default directory. Here it was. When I run the grub make config or update grub, it will apply these changes to the grub.cfg. So here I show you an example for booting manually from grub command line, and you see that how it could be helpful to know how grub works and how boot directory works and what are the details in this directory. So for booting from grub manually, you have your grub command line here. Execute the ls command to see what you have, and find your root for boot. Find your boot directory, your boot partition, I mean, with and also set the root to your proper partition. For me it was ms-1, and also with cat etc fstab I found that which partition is my root. In my case, root was I think dev vda1, and then choose your Linux image, which is boot VMLinus blah blah blah, and also choosing the root file system here, and Init RD boot Init RD image blah blah blah, it doesn't matter the proper version, and then run the boot command, and now you have your Linux. And after that, fix and update grub to complete it. And we are done with this episode. Thank you for watching me. Don't forget to subscribe, like, and share this episode with your friends. Till next episode, bye bye.